talking about similar figures today, okay? Which is going to use proportions. So the math that you have to do today is the same as the math that you did in 2-7. It's just that now you're going to have to set it up from more of a picture format instead of a word problem. It's more of a picture problem a lot of the time, okay? So similar figures, first thing. You need to know that similar figures have the same shape. So if it's a triangle, the similar figure needs to be a triangle. If we're talking about a circle, the similar figure is going to be a circle, okay? But they will have different sizes. Okay, so the same shape, but it's a different size. The way you're going to show similarity with a symbol is a tilde. It's just that little squiggly bar. If you're looking at a keyboard, it's the top left button on a keyboard. When you see that squiggly bar, that tilde, we say is similar to. So for instance, if you look at this setup here, we would say triangle ABC is similar to triangle FGH. That means they are the same shape, they're both triangles, but they're different sizes. Which one's bigger? FGH. The second one is bigger, okay? What happens with that is we will know then that the angles are actually the same sizes, but the sides are proportional. So we can say right now that angle A is congruent to the equal sign with the little tilde over top. That means congruent. So we're saying they're equal. Angle A is the same as angle F. Okay, the way we can tell is if you just look at these letters, A was the first letter, F was the first letter. Okay, so A is congruent to F. So what would B be congruent to? Angle B.
G.
That would be angle G. And then we know that angle C is the same measure as angle H. Okay, so the angles will be the same measure. It's the sides that are proportional. So basically what we're saying here is that the length of AB over the length of FG will be equal to, now go back to your first triangle. If I say BC, what do I need to put that over in the second triangle? GH. Okay, and then go back to the first triangle again, and it would be AC over what? Over FH. Okay, notice what's happening here. On top, those are all the small triangle, and on bottom, they're all the big triangle. Okay, so it always has to be like small over big equals small over big equals small over big. Or I could flip the whole thing, and I could say big over small equals big over small equals big over small. But you need to keep all of them on the horizontal the same figure. Okay, so either the top is all small or the top is all big. Does that make sense? Okay, so if that's the case, let's look at numbers now. I have AB, which is a length of 8, and I put that over FG, which is a length of 12. So that would be 8 over 12. Okay. Then look at BC. How long is BC? 12. Okay, so I'm just plugging into this right now. So 12 over GH, which is 18. So what's my last ratio going to be? What over what?
I see.
That would be 10 over 15. Okay. So they told us these are similar triangles, which means 8 over 12 should equal 12 over 18, which should equal 10 over 15. The way that you can check it is just reduce those fractions. So 8 over 12 would reduce to what? If we divide both by 4, 2 over 3. Okay, what does 12 over 18 reduce to? 2 over 3. Divide by 6, you would get 2 over 3. And then 10 over 15, if you divide by 5, you get 2 over 3. So this tells us that they are in fact similar. They get the same ratio. Okay? Questions on that?
Nope.
Okay. Example, well, before we move on to that. In similar figures, the angles are congruent, side lengths are proportional. Okay, so that's what I just showed you. Angles are congruent, that's all the angles. The side lengths, you can set up a proportion. Okay? Okay, so look at example 1. If I know that triangle ABC is similar to triangle DEF, they want to know what is the length of DE. So they're looking for what is this length. What can we call that right now? X. Just give it an X. We don't know how long it is, so call it X for now. Does anyone see a number in this problem that we're not going to use? Melion.
10.
We will use 10 actually. 18. Right, so if you look at your two figures, I always do shapes here. I'm a geometry teacher. So 10 corresponds to what on the other figure? X, right? Those are in the same spot. So 10 to X. What does the 16 correspond to? The 12, okay? That means 18 doesn't have a buddy over here, right? There's nothing there. So we're not going to use the 18 at all. We want to set up a proportion, something over something equals something over something, with those 4 numbers or variables. Can anyone tell me what that's going to look like? Let's start with 10. 10 over what? 10 over X should equal 16 over 12. Okay, and this is where it's hugely important. You cannot go 10 over X and then go 12 over 16. Do you see why?
Because it'd be like, you can't.
You're switching your order, right? You're flipping. So if you go small to big, then you have to go small to big. In other words, the smaller triangle is all on, nope, the bigger triangle. I said that backwards. Oh, and I did it the wrong direction. That's okay. So these two, right? 10 over X. This is the small side. Okay, let me not confuse you. That's just going to be more confusing. We'll go this way. 10 and 16 come from the bigger triangle. X and 12 both come from the small triangle. Okay? How do I solve that for X? You cross multiply. It's like you've done this before. This is fantastic. So if we cross multiply this, you get 16x equals 10 times 12, which is 120. To solve that, you're going to divide by 16, and you get x equals 120 divided by 16 is 7.5. Okay, and they asked you what is the length of DE. That was our x, so 7.5 is your answer. Does that make sense?
Yes.
Okay, any questions?
Wait.
Melion. Okay, for this next one, we're going to draw a picture. Sometimes when you're trying to measure things, you can't just like measure it, like a skyscraper, right? We cannot just measure a skyscraper with, although now I wonder if the iPhone would do that, because the iPhone has that measure feature. It's really cool. But I don't know if it would do something that huge. So sometimes when we can't measure it with a ruler or a yardstick or a measuring tape, we can measure it a different way. We can measure it indirectly, we call it. So this is indirect measurement that we're talking about. And the sun actually plays a huge role when you're trying to measure something indirectly. If you think of it as there's a girl or a boy, I don't care what it is, standing here next to a building, which is here. This is not going to be to scale, sorry. Oh, I guess it's not. No, it's not to scale. We want to know how tall this building is, and we don't have a way to measure it just with a yardstick or ruler or anything. But the sun is shining down at an angle, and you'll just have to take my word that this is how it works. You'll learn more about this in geometry. The angle that the sun shines at here and here to create a shadow right? So this is a shadow on the bottom, and this is a shadow on the bottom. That angle would be the same because the sun's in the same spot compared to the building and the girl. And they're both standing up straight. So we end up with these two triangles that are proportional. They are similar triangles. What we want to know is if the girl is 5 feet tall and her shadow is 3 feet long, and then we can measure the shadow of the building because the building's on the ground, right? So we can just measure off that shadow, and we find that the shadow is 15 feet. Just realized that I wrote something down wrong on here. And we want to know how tall the building is. That's our X here. Do you see a proportion that you can set up?
Yeah.
What would it be?
30, 15, and 5 over.
Right, we can say shadow over shadow equals height of the girl over the height of the building, right? How do you solve that? Cross multiply. So 15 times 5 is 75 equals 3x. And then you divide. What's 75 divided by 3? Nobody does? Somebody knows this right now.
15.
That would be 15, 30, 45 times 3. 25, right? 25, 50, 75. So the height of that building would be 25 feet tall, right? We were talking about feet, feet, and feet, so our answer is going to be in feet. And then you just cross multiply it once you set up the proportion. Does that make sense?
Yeah.
Questions? What? This is the proportion. Is that what you're asking me? Yeah. Yeah. So what you set up for me, that what over what equals what over what. That's your proportion to solve. Okay. Last two things. This first one that we're going to talk about is called a scale drawing. Have you heard of a scale drawing before? Yeah? Where do you often see scale drawings? Maps, blueprints, they're all right here, right? Oh my word. Blueprints, floor plans for like a house or a building. A map, you often see a scale drawing, right? Something that's not actually 20 feet long, they mark as 20 feet long. In reality, it's 85 feet long, okay? So for a scale drawing, this is a drawing that is similar to an object or place. In other words, the sides are proportional and the angles are the same, just like we did in that first set of triangles, okay? They are similar, they are proportional. So this first question, it says, what is the actual distance from Jacksonville, which is here, to Orlando, which is down here, based on that ruler that you see? And then here's the important piece of information. They tell you the scale. So if you look at the scale, they're saying 1 inch on the map is actually 110 miles in reality. Drastic difference, okay? So 1 inch is 110 miles. We want to know how far is it from Jacksonville to Orlando in miles. Can you tell me how far it is from Jacksonville to Orlando in inches?
2. Wait.
It's not 2.
1.5.
It's not 1.5.
What? Are you sure 1.25?
1.25. Look at the markings here. Here's 0.
It's like the same.
It's not. It's very different. Right? Those are all evenly spaced. So this is 1, and then this is 1/4 more, right? 1/4 of it. So we would say that, do you know an easier way to write 1 and 1/4?
1.2.
1.25. So the distance here is 1.25 inches. Okay? We know our scale. So if we set up our scale to start our proportion, we would say 1 inch over 110 miles equals, and then we have to figure out where our 1.25 inches would go. Remember, this is not conversions. We're not canceling out the inches. Do you remember what I said? You want to keep them straight across from each other. So in this one, we want to put the 1.25 inches on top. What's going to go on bottom? X. That's our unknown. We don't know how big it is. So that's X miles. Okay, that means our answer is going to be what units? Miles. That's what we're looking for, is miles now. How do you solve that? You cross multiply. So you're going to go 110, times 1.25 equals 1 times X, which is just X. So when you plug that in, X comes out to 110 times 1.25 is 137.5 miles. So how far is it from Jacksonville to Orlando? It's 137.5 miles away. Okay?
Like in real life?
Yeah. True story. Okay. Last one. This one, we're doing a scale model. This is so very similar. The only difference is your figure is 3-dimensional now, okay? So it's a 3D model that is still similar to some 3D object. So for instance, if we had a giant model heart, like the one you see here, it says the heart is the ideal size for a person who is 170 feet tall. So they made this model heart. No.
This is the weirdest example.
It's in the book.
I don't like this.
Sorry.
Who's 170 feet tall? Really?
Well, that's the point. It's not for an actual person. They did a model of it
But why?
to see the intricacies of the heart.
It's a jump. It's like,
No, there is no person 170 feet tall.
oh, okay.
They're saying if they made this heart, it would fit in a person that would be 170 feet tall. So it is a 3D version of a much larger heart.
My kids is
The
doing
sun?
That's like all the way.
Okay. So it says the heart is the ideal size. That does not mean there is a person 170 feet tall. This is how big it would need to be for 170 feet. It says, about what size would you expect the heart of a man who is 6 feet tall to be? Okay?
It's big right now.
You're trying to set up a proportion.
It's mad right now.
Okay? The man representing this heart
It's you. Okay.
is 170 feet tall. We want to know, this man, how tall is his heart?
Like small.
What's your proportion?
It's
See,
you.
that's like looking really small.
X over
What you
6
can say.
equals 14 over 170. So we're saying the man's heart over the man equals the giant heart over the giant, right? Does anyone have a different way they would have set this up?
Nope. This is like the way we learned, right?
Okay, here's the other way you could have done it, and it's not wrong. You could have said small heart over big heart equals small man. It's not actually small, he's 6 feet tall, over large man,
So you'd still get the same answer?
right? Yeah, because look what happens. 170 times x and 170 times x are the same.
True.
6 times 14 and 6 times 14 are the same. So you may do it either way.
Wait.
Technically, the way I taught you, you would do, this is like the small version, right? Small heart and small man. This is the large version, large heart, large man, okay? But it's not wrong to do it this way. You'll get the same answer, okay? So let's work this out. If I do 170 times x equals 14 times 6. 14 times 6 is 84. What do you do from here? By what? 170. So many times when people see a problem like this, they're so used to dividing by the smaller number that they go 170 divided by 84, which would get you the wrong thing, okay? You need to divide both sides by 170. So this is gone. You're left with x equals 84 divided by 170. We're going to call 0.49, okay, when you plug that in. Think about what that means, okay? 0.49 is in feet, right? Everything we did was in feet. So think about 0.49. That's close to what number? 50, close to 0.5, right? Close to a half. So that heart is about a half a foot, because we're in feet, right? So about 6 inches tall. So your heart, think about your heart, right? About 6 inches if you're a 6-foot man. Okay?
So if you're like 7 feet.
Well, you could do that, right? If this was true, then you could do 7 feet here instead of 6, and you could see how big that heart would be. Do you want to figure out? Let's figure out Maylion's heart. You're 6 what? 9? 6'8".
6'9", 6'6". I don't know. 6'9".
Okay, so if he's 6'9", 9 inches is what fraction of a foot? 9 over, think of it this way, 9 out of 12 inches, right? If we divide by 3, that's 3/4, okay? So we would say Maylon is 6 3/4 feet tall, right? An easier way to write that would be 6.75 feet tall, okay? So if we're doing, let's go here so we have the comparison, right? That would make this 6.75. How would you set up your proportion for Maylon?
Where's it? I can't find it.
So you have x over what?
6.9.
So you could do, let's do heart over heart, because I want to keep the same things together. So x over 14, right? Heart over heart equals Maylon 6.75 over Gigantor Man at 170. So you're going to go 14 times 6.75 is 94.5 equals 170x. Okay, so divide by 170. 94.5 divided by 170. You get this. Okay? Right now, that's saying feet. So 0.55588 feet is more than half a foot. So we would say if you turn it into inches, multiply by 12, it's about 6.7 inches would be the size of Maylion's heart.
6.7 inches.
Okay?
Buddy.
That's not,
What happened?
yeah, 6.7 inches.
See from what?
Any questions?